Yes, so good evening once again. Let us start the numericals from laws of motion. Okay. So you can read the numerical. This is the 12th numerical from your textbook, which tells us that yes, a spring ball of mass 0.5 kilogram is dropped from some height. On falling freely for 10 seconds, it just explodes into two fragments of mass ratio 1:2. Okay. The lighter fragment continues to travel downwards with the speed of 60 meters per second. Calculate the kinetic energy supplied during the explosion. Okay, so let us draw the diagram roughly. What is happening here is, see, so सबसे पहले ये बात है कि एक स्प्रिंग बॉल जो है उसका मास दिया हुआ है 0.5 किलोग्राम and it's dropped from some height. Okay, so that means suppose this is the height and suppose this is the ground from which it is dropped. यहाँ से उसको हमने ड्रॉप किया, ये हाइट जो है तो वो दिया हुआ है यहाँ पे. That height is not given actually. We can just consider it as h or anything else. But it is given that the ball is dropped from this height, this point here, and its mass is given already. Yes, so mass of the ball is given to be 0.5 kilogram. Okay, and also it falls for 10 seconds. Okay, so ये जो है ये 10 seconds तक वो नीचे गिरता रहता है. फ्री फॉल टाइम उसका जो है वो 10 सेकेंड्स यहाँ पे दिया हुआ है. तो 10 सेकेंड तक नीचे गिरने के बाद वो एक्सप्लोड होता है. सो दिस बॉल जस्ट एक्सप्लोड्स इनटू टू पार्ट्स. सो हियर वन फ्रैगमेंट, मतलब ये जो एक्सप्लोजन है, तो दिस एक्सप्लोजन इज ड्यू टू द इंटरनल एनर्जी which can be just like chemical energy which is stored in a bomb, due to which the bomb just blasts, and because of that the two different fragments are thrown in different directions. So the same thing happens here, and this bomb at this point just explodes into two fragments whose mass ratio is 1:2. That means one fragment will have the mass which is double of the other. Okay, so and it is given that the lighter fragment continues to travel downwards with the speed of 60 meters per second. Okay, that means lighter fragment continues to move in the downward direction with a speed of 60 meter per second here. तो ये 60 meter per second से ये lighter fragment move कर रहा है downward direction में. And at the same time, the we are not given with anything about this another fragment. तो अभी दूसरा fragment जो है तो उसका direction या उसका velocity के बारे में कुछ भी नहीं दिया है. Okay, so if the if was lighter fragment just continues to move in the downward direction, then let us assume that this another fragment, heavier fragment we'll say, will be moving along this line only, maybe either upwards or maybe downwards. Doesn't it is not clear so far. अभी तक ये पता नहीं है हमको कि वो ऊपर तरफ जाएगा या नीचे तरफ जाएगा. Yes, and we want to find out the calculate the kinetic energy supplied during the explosion. तो इस एक्सप्लोजन के दौरान कितना काइनेटिक एनर्जी हमको मिला, मतलब काइनेटिक एनर्जी कितना जनरेट हुआ, तो वो हमको निकाल के दिखाना है. दैट मींस एक्चुअली द सम फॉर्म ऑफ केमिकल एनर्जी हैज बीन कन्वर्टेड इनटू द काइनेटिक एनर्जी हियर इन दिस केस. सो दैट केमिकल एनर्जी व्हिच कन्वर्ट्स इनटू काइनेटिक एनर्जी वी हैव टू फाइंड इट आउट, व्हिच विल बी एक्चुअली द डिफरेंस in the kinetic energy before the explosion and the kinetic energy after the explosion. क्योंकि देखो अगर if suppose there is no kinetic energy obtained from the explosion, then in that case the kinetic energy must be conserved. अगर kinetic कुछ भी kinetic energy यहाँ पे explosion के दौरान नहीं मिल रहा हुआ है तो ऐसे हालत में ये जो काइनेटिक एनर्जी है वो कंजर्व होना जरूरी है, लेकिन means definitely kinetic energy has not been conserved actually. So we can just say that the kinetic energy has not been conserved just because the kinetic energy after the explosion is going to be greater than the kinetic energy before the explosion. So that difference we have to find out. So that means finally we have to find out the difference in kinetic energy. That means the kinetic energy after the explosion minus kinetic energy before the explosion. But for that, we will require the velocities after explosion and even before the explosion also. So let us consider this as a point at explosion. ये जो point है, इस point को हम बोल देंगे P, okay? और ये point जो है, उसको बोल देंगे A, okay? So A से लेके P तक ये जो body है, वो free fall, gravity का free fall ओबे करता है, जिसके कारण हम ये बोल सकते हैं कि what will be the speed attained? It is going to be the speed attained by the body after 10 seconds. How will you find it out? 10 सेकंड के बाद उसका स्पीड कितना होगा, तो वो निकालने के लिए हमारे पास फर्स्ट काइनेमेटिकल इक्वेशन है, which tells us that v is equal to u plus at, correct है? So here it is going to be v equal to u plus a into t, where v is to be found out and u, which is the initial velocity, which is going to be 0 just because it is said that the ball is dropped from some height. Okay, drop करने का मतलब क्या है? It was at rest initially before dropping, that's why it will be 0, and plus a is going to be the acceleration due to gravity, which is actually 9.8 here in this case, and that is to be multiplied with time, which is going to be 10 seconds here, so that we can just get this velocity to be simply equal to 98 meter per second here. Okay, so velocity is obtained to be 98 meter per second. This is actually the velocity just before the explosion of this ball. तो इस बॉल के एक्सप्लोजन होने से जस्ट पहले उसका वेलोसिटी इतना था, ठीक है? और ऑब्वियसली मास जो है, तो वो तो हमको ऑलरेडी पता है, मास ऑफ द बॉल वाज गोइंग टू बी 0.5 किलोग्राम हियर. So we can just talk about the momentum before the explosion. Total momentum before the explosion, we can find out. Momentum just before explosion takes place. क्योंकि यहाँ पे इस P पॉइंट पे एक्सप्लोजन हुआ है, तो इस P पॉइंट पे आने तक जो मोमेंटम उस बॉल का रहा होगा, तो उसको हम निकालेंगे m into v करके, where m is going to be actually 0.5 and v is just obtained to be 98 meter per second here, which gives us actually this 49, right? So 49 kilogram meter per second. This is actually going to be the momentum of the ball just before the collision. Okay, and even at the same time, we can just find out the kinetic energy of the whole ball before the collision also. So let us try to find out the kinetic energy of the ball before collision. How can we get that? So see it here. Yes, so the kinetic energy before the collision can be found out by just using the formula half mv square. Collision, it is an explosion, right? The kinetic energy before explosion can be found out by using the formula half m into v square, where m is going to be 0.5 and v square is actually 98 का whole square, correct है? 98 का whole square मतलब ये बन गया 98 into 98 once again, so that we can just multiply this half by this 98, leaving behind 49, and this 0.5 is also equivalent to half, which multiplies this another 98, leaving behind 49, and hence we can just get this 49 into 49, which is actually going to be 24. 49 का स्क्वायर कितना होता है? 49 into 49 will actually be okay. 50 माइनस 1 का स्क्वायर लिख सकते हैं इसको, तो 50 माइनस 1 का होल स्क्वायर जो बन गया 2500 माइनस 2 टाइम्स ऑफ 100 मतलब 200, सॉरी 2 टाइम्स ऑफ 50 मतलब 100 and plus 1 kept as it is, so that we can just get this as 2400 plus 1 मतलब 2401. Okay, so here it is going to be 2401 joule. This is actually going to be the total kinetic energy before the explosion. Okay, तो बिफोर एक्सप्लोजन हमने सब कुछ निकाल लिया है. ओके, बिफोर एक्सप्लोजन वाला काइनेटिक एनर्जी भी हमने निकाल लिया. At the same time, we also found out the momentum before the explosion and velocity also before the explosion. Okay, now let us focus on what happens after the explosion. Just after the explosion takes place, the body of mass 0.5 just gets split up in two parts whose mass ratio is 1:2. Okay, so yes, here in this case the mass ratio is given here. So mass ratio अगर दिया है तो ऐसे केस में we should be able to find out the mass of each fragment. Okay, so if suppose this mass m just gets split up into two parts, one is going to be m1 here and the other one is going to be m2. Okay, and it is given that m1 is to m2 is actually equal to 1:2, and let us assume that this m1 is the lighter part and m2 is going to be the heavier one. Okay, so m1 is to m2 equal to 1:2 and m1 plus m2 is actually 0.5. So sorry, m1 plus m2 is going to be 0.5 because इसके उसके ही वो पार्ट्स है ना दोनों, तो इसलिए इन दोनों मासेस का सम जो है वो तो 0.5 रहने वाला ही है, लेकिन दोनों का जो रेशियो है वो 1:2 रहने वाला है. Okay, so how much will be m1 and how much will be m2 in terms of m? If you just try to find out, then अभी देखो m1 is to m2 equal to 1:2 का मतलब क्या हुआ, m1 upon m2 equal to 1/2 मतलब m2 is going to be 2 times of m1, right? So if you just put this value here, then we can get this as m1 plus 2 times of m1 is equal to 0.5, or 0.5 can be expressed as small m only. So it means that 3 times of m1 is actually going to be small m. Remember that this small m is nothing but 0.5. We'll just try to write it in terms of small m only and m2 as well. So that means m1 is actually going to be m/3 here. Okay, m/3. And since m2 is equal to 2 times of m1, so we can just get that m2 is actually going to be 2 times of m/3, no doubt. So m1 and m2 has been obtained in terms of m, which is the total mass of the body before the explosion. Okay, so these are the masses of these two fragments. Okay, now we have to find out the total momentum after the collision. Can you find it out? See here, the total momentum after the collision, because we already found out the total momentum before the collision. If you just find out the momentum after the collision and equate them, then we will be able to find out the velocity of that heavier part, because already it is given that the lighter part moves. Abhi lighter part matlab kaun hai, wo m1 hai actually. Okay, this m1 is the lighter part which moves with the same velocity in the same direction, that is of 60 meter per second. Okay, तो 60 मीटर पर सेकेंड इतने वेलोसिटी के साथ ये लाइटर पार्ट मूव कर रहा है डाउनवर्ड डायरेक्शन में. ठीक है, तो दूसरा जो पार्ट है उसका हेवियर पार्ट, उसका वेलोसिटी कितना होगा, कितना है, वो निकालने के लिए हमको लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम अप्लाई करना पड़ेगा. सो इन ऑर्डर टू डू दैट विल जस्ट try to find out the total momentum before after the explosion. So let us try to find out the total momentum after explosion. Okay, what is the total momentum after the explosion? Because after the explosion, the single body just breaks up into two parts. So the total momentum of these two parts combined together will actually be the total momentum after explosion. So you can just say that this m1 into v1 plus m2 into v2. This is actually going to be the total momentum after explosion, where m1 is already given, already we have found out to be, we have expressed it in terms of, ओके m1 को हमने यहाँ पे एक्सप्रेस किया हुआ है m के फॉर्म में, जो कि m/3 है here. So इसलिए यहाँ पे उसको हम डाल देंगे, तो here it becomes m/3 as it is into v1. अभी m1 मतलब लाइटर पार्ट है, राइट? और यहाँ पे दिया हुआ है ऑलरेडी कि लाइटर पार्ट कंटिन्यूज टू मूव इन द सेम डायरेक्शन डाउनवर्ड्स विद द स्पीड ऑफ 60 मीटर पर सेकेंड, राइट? ये दिया हुआ है ऑलरेडी. सो इसका मतलब ये जो वेलोसिटी है 60 मीटर पर सेकेंड, this velocity must be the v1, that is the velocity of the first part after the collision or explosion. Okay, so here we have to multiply this m/3 by 60 here. Okay, and then we'll have to multiply this m2, which is nothing but 2m/3 here. So this is the heavier part after the explosion, 2m/3, which must be multiplied by v2 here, v2, which is not given directly, but we have to find out it by using the law of conservation of momentum here. So let us call it as v2 only, and then we will be able to express this. This is the total momentum after the collision, the explosion. That means we can call it as p2 here, and here this is the momentum before the explosion, which is denoted by p1 here. Okay, so but according to the law of conservation of momentum, we can just say that law of conservation of momentum tells us that this p1 must be actually equal to p2, where the p1 is the momentum before the collision explosion. So what is p1 here? It is this 49 kilogram meter per second. So here we can just replace this 49 as a single value in LHS, which should be equal to p2, where p2 is made up of two terms, one of which is this m/3 into 60, and the second one is 2m/3 into v2 here. So we can just put them as it is. So here it will be m/3 into 60 plus, here it is 2m/3 into v2, where v2 is to be found out actually. Yes, so here we can just cancel out this 3 and 60, leaving behind 20, and get this as 49 is equal to, if you just take m common from this bracket, then we can just be able to obtain finally this as m into bracket. What is left in the first term? It will be 2 here, 20 here, plus from the second term we can just be left with 2/3 times of v2. Okay, where v2 is to be found out. Okay, but m is already given in the question itself, that is of 0.5 किलोग्राम. ये जो बॉडी का जो टोटल मास है, तो वो तो ऑलरेडी हमको दिया हुआ है, जिसको 2.5 किलोग्राम हम बोल सकते हैं. So if you just put it here, then we can be able to get the next step, that is 49 is going to be equal to 0.5 into 20 plus 2/3 v2. Okay, and then we can just be able to obtain this 0.5 in that side. अभी इसमें याद रखो ठीक से कि 0.5 का मतलब क्या होता है 1/2, एंड 1/2 अगर उस तरफ चला गया तो वो 2 हो जाएगा. तो इसलिए यहाँ पे 49 into 2 आ जाएगा, जो कि 0.5 का रेसिप्रोकल है, and that will be equal to actually 20 plus 2/3 times of v2, right? So this is 2/3 times of v2 kept as it is, and then we'll be able to get this in the next step, that is 498. Okay, 49 into 2 comes out to be 98, which is actually going to be 20 plus 2/3 v2. Okay, if you just transfer this 20 in that side, so it becomes minus 20. and 98 minus 20 comes out to be 78 actually. So here it is going to be 78, which is going to be equal to 2 by 3 times of V2. And then in order to find out this V2 here, we'll have to take this 2 by 3 in that side, so that in the next step we can just get this as yes, this is the next step. 78 multiplied by ये 3 जो है वो नीचे था, वो इस तरफ आके ऊपर चला जाएगा, और 2 जो कि ऊपर था तो यहाँ पे आके नीचे आ जाएगा, and that will be equal to V2 here. So finally we are going to get this V2 to be simply equal to 2 ones are 2 39s are, right? So it can get this as a 39 into 3, which is actually going to be 40 into 3 is 120. So 39 into 3 will be 127. Sorry, 137. Okay, so 137 meter per second. This will actually be the velocity of the second body or second fragment after the explosion. Okay, once you get that, we can just now work out the change in kinetic energy, because we want to find out the kinetic energy during the explosion. So let us try to find out the total kinetic energy after the explosion. See here, kinetic energy after explosion. How we can get that? Because after the explosion, there are 2 parts of the body, and that's why we can just find out the kinetic energy of each part and just add them together so as to get the total kinetic energy of the body after the explosion, so that we can just get this as half m1 v1 square. Okay, so this is half m1 into v1 square plus half m2 v2 square. So this is going to be actually the total kinetic energy. Okay, v2 is equal to 1 centimeter. Right side. Sorry. 114, 120, no? Sorry, 43 is a 120, right? Correct. It will be actually 117 only. Yes. Yes, correct. Okay. Chalo, okay. So then we can just be able to put this m1 and m2 as it is here also. So in this case, half of m1 is going to be put here as m by 3, and m2 is going to be 2m by 3. Okay, so that we can get this half into m by 3 into v1 square plus half of m2, which is 2 times of m by 3 into v2 square, where half and m and 3 m by 3 can be taken common. Okay, so that means m by 6 can be taken common actually. Okay, m by 6. ये देखो ये m और ये नीचे 6, इधर भी है m और नीचे 6. So if we just take m by 6 common, then what will be left inside? So it will be v1 square plus 2 times of v2 square. Yes, because already m by 6 has been taken out. Okay, now it is the time to put the value of m here, which is 0.5. So this is 0.5, and that is to be divided by 6, and this is to be multiplied with v1 square, where v1 is actually given to be 60. So we have to put it as it is. So this is going to be 60 and whole square plus 2 times of v2 square, where v2 is actually 117. yes, 117 और उसका स्क्वायर. Okay, so in the next step this will be simplified. Abhi 0.5 means again it is half, right? So half divided by 6 comes out to be 1 by 12 actually. So it is going to be 1 by 12, and inside the bracket we can have this 60 whole square. What is 60 ka whole square? It is 3600, right? And here it is 2 times of what is the square of 117. Just look for it in the log table, in the square of in the table of squares. सभी स्क्वायर्स का जो टेबल होता है तो उसके अंदर अगर हम देखेंगे ठीक से तो हमको वो मिल जाएगा आराम से. और जस्ट वी कैन जस्ट टेक द कैलकुलेटर हियर एंड जस्ट वर्क आउट द वैल्यू. Yes, 117 into 117 again, which actually happens to be 13,689. Okay, 13,689. Yes, it is going to be 13,689, and this is to be multiplied with 2 here, so that we can just get this 1 upon 12. In bracket it is 3600 plus, here it is going to be 2 9s are 18, 1 carry, 2 8s are 16, 1 plus 1 17, 1 carry, 2 6s are 12 plus 1 13, again 1 carry, 2 3s are 6 plus 1 7, and 2. Okay, so this is the, and if you just add these two, again you can just have this calculator and add these two. 3600 plus 27378, 27378. Okay, it comes out to be 30,978, 3978. So it is going to be 3978. If you just divide it by 12, so it comes out to be 2,581. Okay, 2581.5. Joule. Okay, so this is actually going to be the kinetic energy after the explosion, but we already find out the kinetic energy before the explosion, which is actually going to be this much here. This is kinetic energy before the explosion. So what is the kinetic energy supplied during the explosion? So kinetic energy supplied during explosion okay, it's going to be the difference of these two. So let us call this one as K1, okay, and this, the kinetic energy after the explosion is going to be K2 here, suppose. Okay, ये K2 हो गया, तो यहाँ पे हमको क्या करना है, K2 में से K1 माइनस करना है simply. So K2 minus K1 comes out to be, so K2 is going to be 2581.5 minus 2401, which actually comes out to be So again, we have to subtract this. $180.5. Okay. So here it is going to be 180.5 Joule. Okay. The answer given here is approximately the same. Actually might be शायद उन्होंने G का जो वैल्यू है वो 10 लिया होगा. चेक करेंगे ठीक से. अगर G का वैल्यू 10 लेके अगर पूरा क्वेश्चन अगर सॉल्व करते हैं फिर से, तो थोड़े थोड़े आंसर्स चेंज हो जाएंगे. जस्ट वी कैन सी क्या क्या चेंज होगा वो हम यहाँ पे रेड कलर वाले एरो से यहाँ पे लिखेंगे. देखो सबसे पहले ये वेलोसिटी जो है आफ्टर एक्सप्लोजन, बिफोर एक्सप्लोजन, वो चेंज हो जाएगा because G is going to be 10. So we can just get this as 100 actually. And this 100 multiplied by this 0.5 will actually become 50 here. तो ये 50 बन जाएगा. And kinetic energy after before explosion will actually become so 1 by 2 into 0.5 into 100 into 100. तो मतलब वो 2500 बन जाएगा राउंड फिगर. ओके लेट अस चेक. ये 98 जो है वो 100 बनने वाला है ना, तो ये 98 के बदले यहाँ पे 100 आएगा. इधर भी 98 के बदले 100 आएगा. इसके कारण 100 इंटू 100 10,000 बनेगा. और 10,000 का 1/4 कितना होता है, तो वो होता है 2500 ऑटोमेटिकली. सो दिस विल बी एक्चुअली द एनर्जी बिफोर द एक्सप्लोजन इन जूल. ओके बाकी सब तो एज इट इज है. सिर्फ यहाँ पे यस ये V2 जो हमको मिला है वो तो करेक्ट होगा, उतना ही आएगा. नहीं P2 जो है ना, वो P2 हमने यहाँ पे 49 यूज किया राइट. P2 के बदले 49 के बदले हमको क्या यूज करना होगा, 50 यूज करना होगा. 50. So if we just put it as a 50, then this 50 will get multiplied by 2 so as to become 100 here. So यहाँ पे इस 98 के बदले यहाँ पे 100 आ जाएगा, जिसके कारण ये 20 उस तरफ जाएगा, तो 100 माइनस 20 मतलब 80 हो जाएगा. इस 78 के बदले क्या आने वाला था, 80 आएगा. 80, जिसके कारण 80 को अगर हम 3/2 से मल्टीप्लाई करेंगे इधर, तो 80 multiplied by 3/2 actually becomes 40, 3s are 120. Yes, so actually ये जो है वो 120 आना था. V2 का जो वैल्यू है वो 120 मीटर पर सेकेंड आता था अगर हम G का वैल्यू 10 लेते थे तो. Yes, and then we can just do all these things as it is. And finally here at this point V1 is to be put as 60 and V2 is going to be put as a 120 here. So यहाँ पे अगर हमने 120 डाल दिया तो उस 120 का स्क्वायर हमको करना पड़ता है. जैसा कि तो ये 3600 प्लस यहाँ पे 120 का स्क्वायर कितना आता था, 14400 करेक्ट है. जिस तो यहाँ पे इसलिए 2 इंटू 14400 जो कि 12 का स्क्वायर है और उसके ऊपर 2 जीरोज हमने लगा दिए, जिसका डबल करने से हमको ये मिलेगा 28800. तो यहाँ पे आ जाएगा 28800. And if we just add it with this 3600 here, then at this point, or better, we can just multiply each term by 1/12 here in the bracket. So here it is the 36. Okay, just wait. Just add these two terms, 3600 plus 28800. 288 plus 36 कितना होता है, देखो 288 plus 2 is 290. 290 plus 30 is 320 and plus 4, 324. Okay, so here it is going to be 324 and 00 as it is. Yes. बराबर है ना, चेक करो एक बार. Yes, correct. So now we can just divide this by 12, and what we can get here is the 12 ones are 12 twos are, so here it is 2, 12 twos are 24. If you just subtract 24 from 32, it gives 8, and it becomes 84 here. So 12 sevens are 84, and here 2 zeros extra, and this is going to be in joule. Okay, so it becomes very simple actually. हमने वो g का वैल्यू 9.8 लेके थोड़ा सा कॉम्प्लिकेटेड कर दिया और कैलकुलेशंस थोड़ा बढ़ गए, बट यहाँ पे ये 2700 आ रहा है, और यहाँ पे जैसा कि हम जानते हैं ऑलरेडी, इट इज गोइंग टू बी 2500 joules actually here. So we can just subtract these two so as to find out the total kinetic energy supplied during the collision, so explosion. So 2700 minus 2500, it comes out to be 200, which is already there in the textbook. Okay, तो ये जो आंसर उन्होंने निकाला है वो एक्चुअली जी का वैल्यू 10 देने से निकाला है, तो यहाँ पे देना चाहिए था जी टेक जी एज अ 10 मीटर पर सेकेंड स्क्वायर. ओके, yes. So that's all about this question. Let us move to the next question. If you want to take the screenshot of this, you can just do it. Yes, let us go to the next question. Yes, just read this question carefully. A marble of mass 2m traveling at 6 centimeter per second is directly followed by another marble of mass m with double velocity. After the collision, the heavier one travels with the average initial speed of the two. Okay, calculate the coefficient of restitution. Yes, so let us consider these two marbles. One is this one here. Okay, and the second one is this one here. So a marble of mass 2m. Okay, so ये जो marble है ये 2m mass वाला है. Okay, traveling at 6 centimeter here. So this marble is actually traveling at the speed of 6 centimeter in this direction per second. Okay, 6 centimeter per second. Yes, and it is followed by another marble of mass small m with the double speed. That means this smaller marble with mass small m here will be traveling with the double speed in this case. तो इसका जो speed है वो इसका double मतलब 12 मीटर पर सेकेंड होगा जरूर. So this is going to be 12 centimeter per second, and the mass of this marble is m only. Okay, and after the collision, the heavier one travels with the average speed, initial speed of the two. Okay, so can you find out the average initial speed of the two? What is the average initial speed of the two? मतलब इन दोनों मार्बल्स का एवरेज इनिशियल स्पीड कितना हो गया? तो देखो एवरेज इनिशियल स्पीड कितना है दोनों का, ये एक का 12 है और एक का 6 है, तो इन दोनों का एवरेज निकालने का मतलब हुआ कि हमको ये 12 plus 6 और that is to be divided by 2 here. That means this is going to be 18 by 2, मतलब ये 9 हो गया. So 9 centimeter by centimeter per second. This is going to be actually the speed of heavier one. So heavier after collision, after collision. So here that means this is the speed of heavier मतलब क्या 2m वाला है क्या नहीं. तो 2m वाला जो इसका जो स्पीड है the speed of 2m after collision. Okay, this is going to be actually 9 centimeter per second. And we can just call these two as U1, that is 12 meter per second, sorry, 12 centimeter per second. And this one will be called as U2 here. That is a speed of initial speed of the second body, which will be 6 centimeter per second. And then we have to find out the coefficient of restitution. अब देखो coefficient of restitution के लिए हमारे पास formula है जो कि हम जानते हैं already. Coefficient of restitution is found out by the formula V2 minus V1 upon U1 minus U2. करेक्ट है? तो ये फॉर्मूला तो है हमारे पास, नो डाउट, लेकिन यहाँ पे V2 नहीं है या V1 नहीं है. यस, सो दिस इज एक्चुअली V2 itself. यही तो V2 है. V2 is the average speed of initial speed of both of the marbles, which is going to be the speed of second body after the collision, which is obtained to be 9 centimeter per second. But in order to find out this V2 here, we'll have to use the law of conservation of momentum. Okay, so according to the law of conservation of momentum, we can just get that M1 U1 plus M2 U2, which is going to be equal to M1 V1 plus M2 V2. Okay, so M1 is how much? It is M only. Into U1 is 12, correct? Plus M2 is going to be 2M actually. And U2 is going to be 6 here, which is must be equal to M1 is again M into V1 is to be found out, plus M2 is again 2M. Okay, so V2 is already obtained to be 9. Yes, and then if we just have this add up together, so 12M plus 12M actually becomes 24M, right? So here in the numerator, in the LHS, we are going to be this, have this 24M. Okay, and here it is going to be M, where it can be taken common, and we'll be left with simply V1 plus 18 inside the bracket, so that this M will get cancelled, and hence we can just left with 24 is equal to V1 plus 18, so that V1 can be obtained from here. So V1 can be obtained to be 6 centimeter per second here in this case, right? So if we use this V1 here, this formula, then we'll be able to find out the coefficient of restitution, which is going to be V2, that is 9, minus V1, which is 6, upon U1, which is 12, minus U2, that is 6. So that we can just get this as 3 divided by 6, which actually comes out to be 1/2, matlab 0.5. That's it. It does not have any unit. So 0.5 is going to be the final answer. That is the value of coefficient of restitution in this case here. Yes, let us take the screenshot if you want. Okay, so we have just done these 2 questions today. The first question was actually too much long. That's why this much time was required. Okay, so let us go to the next questions in next lecture. ठीक है, तो next lecture में हम बचे हुए questions कर देंगे. ठीक है, on Monday. Yes.